In lesson 8.3, we're going to talk about exponential growth and decay. And the first thing we're going to do is graph this 3 to the 1 times 1/2 to the x power. Now the basic exponential formula is y equals a times b to the x power. And so if you notice, a and b will be numbers. In this case, a is 3 and b is 1/2. And so our variable x is an exponent, okay? So that's why we're going to call this an exponential function. So we've got, that's our basic form that we're looking at. Now for these, that when I ask you to graph them, if there's not anything added or subtracted to any of these things, then it's not got a transformation of any kind. So that means you can pick numbers around 0 for your x's. So we're going to choose every time for these -2, -1, 0, 1, and 2. And then we have to figure out what y is. And so y is 3 times 1/2 to the -2 power. Now what that means, remember we've just been doing exponents, so that means that's the same is 3 times and over 1/2 squared, which is then 3 over 1/4. Now when you divide by a fraction, if you remember, what you do is invert and multiply. Some of your teachers have said keep, flip, change. I always invert the denominator and multiply it. So what that means is it's going to be 3 times 4 over 1. 1/4 inverted is 4 over 1. So when you divide by a fraction, your number gets bigger. And so 3 times 1/2 to the -2 is 12. Then we have 3 times 1/2 to the -1 power, which is 3 divided by 1/2. When we invert and multiply, then we have 3 times 2 over 1, or 6. Notice we divided by 2. Each time we multiply by 1/2, we're dividing by 2. Here we have 3 times 1/2 to the 0 power. Well, anything to the 0 power is 1. So 3 times 1 is 3. 3 times 1/2 to the first power is 3 times 1/2. So that's going to be 3/2. And we're going to make that a decimal because it's easier to graph a decimal. So that's 1.5. And 3 times 1/2 squared is 3 times 1/4, or 3/4. And as a decimal, that's going to be 0.75. Now we need to put those numbers on our graph, with those values on our graph. So we're going to go over here. And at -2, we're off the charts. We're up here at 12. At -1, we're at 6. Right there. Okay. At 0, we have 3.03. 1, 1.5. And at 2, it's 0.75. And if we connect this, it's going to look something like this. And if you divide by 2 every time, as we go here and keep dividing by 2, we never get to 0. We get really close, but we never quite get there. It becomes, and it never goes negative. It just gets closer and closer and closer to 0. So let's look at what happens to the function, the y value, as the value of x increases. Well, as x gets bigger, okay, as x gets bigger, y then decreases or gets smaller. Y decreases or gets smaller. So as we travel from left to right on this curve, you can see as x is going to the right, y is getting smaller. Now let's look at the next page where we have a different kind of graph. It's still an exponential equation, but this time we've got 3 times 2 to the x instead of 3 times 1/2 to the x. So we're going to construct our table using the same x values that we had before. And so we have 3 times 2 to the negative 2 power, which is going to be 3 over 2 squared, or 3/4. So that's 0.75. Then for the next one, we have 3 times 2 to the negative 1, which is 3 over 2 to the first, 3/2, and that's going to be our 1/2. 3 times 2 to the 0 power, again, is 3, so that point's on both the graphs. 3 times 2 to the first is 6, and 3 times 2 squared is 3 times 4, or 12. So you notice these are the same y values, but they've reversed. So now our value at negative 2 here is our smallest value. At negative 1, we're at 1/2. 0, 3 is the same. We have 1/6. And we have 2 is at 12. And now as it approaches 0, it's approaching the x-axis going towards the negative as x is getting smaller. Whoops, let me go back. So let's see if I can draw a better line and go through these points. And as we curve around here, our x tails off. And again, it never crosses that x-axis. It just gets closer and closer and closer to the x-axis as you go to the left. But we approach these the same direction. We want to ask the same question. As on the previous question, what happened as the x got larger, the y got smaller? On this graph, as x gets bigger or increases, your y is increasing. It's also getting bigger. So as x goes to the right, your y value it's going up. It's increasing. So what that means, for this section, we're talking about exponential growth and decay. So when you have the value, the value you need to pay attention to is this b. And b is the value that has the x on it. Okay. So this b value here is the one you need to look at. That's the value with the x. As b is between 0 and 1, make my highlight a little bigger. In other words, b is smaller than 1, but it's not negative. It's between 0 and 1. Then the value of y, as y increases, so this is basically the question we asked on the other page. As y increases, okay, then that is if x is getting smaller, so that's an example of exponential decay. Radioactive decay. There's a lot of the applications to this exponential functions, exponential growth and decay, and use of logarithms in science. So in this case, it is exponential decay. And when the value of x is bigger than 1, a number greater than 1, then as x increases, Remember, in this case, y was going up. So as x increases, y also increases. So this is an example of exponential growth. All right. Now in this particular section, I want you to be able to look at these equations and distinguish whether they're growth or decay just by looking at them. That tells you whether they're, if it's decay, the basic graph tails off to the right and flattens out. If it's growth, then it starts kind of low and then it increases rapidly. And so they're opposite graphs of one another. And so I want you to be able to look at the equation and know what the basic shape of the graph would be. So we're going to look here. And we're going to go, remember our basic equation is up at the top of the page, but I'll write it again here. Y is equal to A times B to the x power. So in this case, there's just a number raised to an exponent. So the 5 is the b. The b is what the exponent is on. If there's nothing in front of it, then it's 1. So a in this case is 1. 5 is obviously bigger than 1. So this equation would graph as an exponential growth. This is growth. Now looking at the next one, a again is 1 because the exponent is on 0.4. So 0.4 is your b. That's between 0 and 1. So this one is exponential decay. Now C and D have an A. Y in this case is 8 times 0.25x. So A is 8. B is 0.25. And B is what you look at to determine growth and decay. So this is less between 0 and 1, so this one is also decay. And the last equation on this particular homework, or this particular set of notes, A is 4. B is 2.5. Even though there's a decimal in that, it's still bigger than 1. Same with an improper fraction. If the fraction is more than 1, it's going to indicate growth. So this is a growth exponential equation. This is exponential growth as we graphed it.